2012 Projectiles question 3a. A particle is projected with a speed of 98 meters per second at an angle alpha to the horizontal. So here's my alpha, here's my 98, and it's going to land down here at 940.8 meters away from where it started. We're asked to find two values of alpha. So we're given the range, given the speed, don't know the angle. That's what we're looking for. So my initial vector here is going to be u, which is 98 cos alpha in the I direction, plus 98 sine alpha in the j. The time of flight we can get by allowing s of j to be equal to 0. So my ut plus a half at squared, and there's no incline here, so a is equal to minus g. So 98 sine alpha minus g over 2 by t squared is equal to 0. Left out my t, so if we factor out my t's, I'm going to get 98 sine alpha minus gt over 2 equals 0. So my initial time of t is equal to 0, and 98 sine alpha would have to be equal to gt over 2 for the bracket to be equal to 0. So 298 or 196, leaving out everything now, sine alpha is equal over g is equal to t. 196 sine alpha over g will be the time to get to this point here. So now I can use my range, s of x or s of I. That's going to be equal to ut, because we don't have any acceleration with a non-incline for my I direction. So 98 cos alpha by the time, which is 196 sine alpha over g, and like 9.8 does divide into 196. I think it must be 20 of them. So we're going to have 20 by 98. 980 twice is going to be 1960 cos alpha sine alpha has to be equal to my range, 940.8. So to simplify this down, if I can get a 2 cos alpha sine alpha, 2 cos alpha sine alpha is equal to the sine of 2 alpha, that should help here. So if I take a 2 out of the 1960, I'm going to get 2 cos alpha sine alpha, and well, I would have a 980, 2 980s equals 940.8. Now I'm going to be able to change my 2 cos alpha sine alpha. Sorry, I wrote over here sine alpha, sine 2 alpha. So I'm going to get sine 2 alpha is equal to 940.8 divided by 980. So this would be able to give me an angle here. So if I type that into calculator, I'll just sine 2 alpha, let me get the decimal first, so write it down. Sine 2 alpha is equal to 0.96. The inverse sine of 0.96 will give me an angle of 73.739, 73.74. So alpha in this case will be 36.87 degrees. 87 degrees. Now where else am I going to get an angle like this? So if I draw an angle here of, we know cos positive, all positive, sine positive, so it's in here, we're looking for an angle in this sector, tan positive, the angle has to be the same size as this one, 73.74 degrees. So if I draw that angle there, just rub out my s, 73.74. This angle here, the other angle, that will give me an inverse sine of 0.96, or getting the sine of the angle to give me 0.96, it's going to be 180 minus 73.74. 0.74 degrees, and that will be 106.26, 106.26 degrees. So that alpha will be 38 or 36.87 or 106.26 degrees. And I haven't divided this one by 2, so that will be 53.13. So the 53.13 and the 36.87. And we're asked to find in part 2, I think I put it down, the difference in the times of the flights. Well, we have the time of flight. Time of flight is 196 sine alpha over g. Time is equal to this one, 196 sine alpha over 9.8. So if we put our first angle in, 36.87, T1 is equal to 196 sine 36.87 divided by 9.8. That's going to give me exactly 12 with a load is 12.0000, something like that, so 12 seconds. And the second time, T2 is equal to 196 sine 53.13 divided by 9.8. That's going to give me, 16 seconds. So the T2 minus T1, the difference in times, T2 minus T1 is equal to 4 seconds.